Alright, 7.5. Need a new video? I actually redid this whole section because I found a ton of mistakes on my notes. And I think they're loaded now. Okay, so this is a totally new section. I tiptoed through it. When I went through this to check the back of the book, and I thought, oh, this is wrong, this is wrong. They weren't wrong. I just had done the simple, straightforward answer because I was in a hurry. And the book has done the complicated answer. So the simple, straightforward answer really is for me to do the algebra and plug this in a calculator. Now, your calculator spits out what I call function answers. And I talked about this a little bit ago. Math majors and engineers especially, they like to know when I put this in the calculator, I get this answer. When I put this answer in, it comes right straight back to where I started. They like that one-to-one setup. That's the whole idea with the function. I go to Florida and I stay in this hotel room. I come home and I stay in my house. One-to-one. I know where I'm going. I know where I'm coming back to. Math is really not like that. It is simplified so that you can work on complicated problems by doing this simple piece and then get bigger to the complicated part. And that is what I did last time. I was in a hurry. I was trying to get caught up. I just rolled through these and put the simple answer down and went on with the rest of the sections. Now, on this one, I have tried to do a combination of answers in case you are interested. I will take any of these three answers. I'll take the simple one, I'll take the technology one, I'll take the unit circle one, whichever one you prefer. If you want to write all three down because this is the last time you're ever going to see it in your life and it's all down here, I'll take that too. So, but this is still algebra. It's a different language, but it is still algebra. You still have that equals mark, and you still have all the stuff that happens on this side and all the stuff that happens on this side, and you must maintain three rules. Don't divide by zero, maintain your balance, and then treat everybody fairly. Every single math rule you can come up with is one of those three. Don't divide by zero, maintain your balance, treat everybody fairly. Those three rules are all of the stuff. Like in number one, first thing I did was take the inverse cosine, which is that little cosine to the -1, remember, to both sides. I maintained my balance, did the same thing to both sides of the equals mark, and I treated everybody fairly. I did the same thing to every little piece. The inverse cosine and cosine go away. I have x equals inverse cosine of the square root of 3 over 2. And I wrote in parentheses, that really means at what angle is the cosine of the square root of 3 over 2. You've got a unit circle answer, you've got a calculator answer, and you've got a infinite answer. So your calculator spits out 30 degrees, which is pi over 6. Your unit circle spits out 30 degrees, or pi over 6. Your combination answer is the 330 is also the same thing, but that's not a function answer. That's the second one. But your calculator will limit itself to quadrant 1 and quadrant 2 for cosines. That's the way it's made. Actually, it should be 1 and 2 this way. So I tiptoed through these. I didn't skip very many steps at all. I wrote down solution 1, which is going to be the unit circle. Then I would do solution 2, which is the next non-function answer you would get from the unit circle. And then I did 3, the calculator answer, or the function answer. And sometimes you've got duplicates, and sometimes you don't. Let's see. I'm talking about how this is the same thing as algebra, like on 9. Trying to get cosine by itself. Where's the ones where I have different powers? Oh, I talked about the scaffolding method on 11. I do think you should know what people are doing to you. We teach in an educational system called scaffolding, which means in 6th grade I teach you a little piece of the bottom level. In 7th grade we teach you a little piece of the bottom level plus like one rung up, and every time you build. That's why our math teachers and actually other teachers say you need to learn this so you can do this later. That's scaffolding. The problem is the bottom layers look easy, and a lot of times you can just look at them and see the answer. Like if I tell you x plus 2 equals 10, or when you're very small in elementary school I say what number plus 2 gives you 10, you can see those. You aren't thinking subtract 2 from both sides, do all the steps, yada yada yada. You know that. You've done enough of it on your fingers. You can even do it on your fingers. I need 10, I got the 2, that leaves me with the 8, you know. But you're supposed to use those very simple answers, or those very simple problems, to apply the steps that you realize you did into larger ones. There are two issues with that. Calculators mean you don't have to look at the steps. You don't have to process them. You don't have to think about what your brain is doing because you're not doing anything. And you don't have to remember them. Even if you worked for a while without a calculator, once you get used to it, you have forgotten how your brain used to say, here's my 10, I need a blank and a 2, take the 2 away, it leaves me 8. So that when the problem becomes 4x plus 15 equals 8.6, you can't reproduce the steps even though you can't see the problem either, or the answer either. It's become too complicated to just look at. But you still haven't thought about all the steps that you did when the problem was real easy and you could just see the answer. Now the flip side to that is we also don't give people credit for the ability to see the answer. Because I don't want you to see the answer. I'm stuck in a public school system. I'm trying to force you to do all the steps and work through that. So what I'm doing is also frustrating people who see the answer and not giving them credit for being able to get through it that fast, which makes them angry, which makes them stop thinking about it. So you have kind of a double-edged problem there. You're either forcing people to not process things by giving them the tools to get through it faster, and then you're not giving them credit for being able to do it faster. But this is still algebra. You are still undoing things and doing them just like you would be if it's regular. The other thing is, this is a textbook. This is in a class. Number 11 is pretty much number 8. The more complicated the problems get, you'll discover that once you do a little bit of the different stuff, the second or third line in, you've got a lower number problem and you're just reproducing it. They're adding stuff on top and you're reproducing that bottom set of scaffolding over and over and over. Let's see, 13, and in case y'all didn't know this, I also have a theater degree, so I read a lot. I'm not just a math person, because here's my little Ralph Waldo Emerson, 2 roads diverged in the woods, and which one you took really doesn't matter as long as you get there. You can do the OCD math way, which is to rationalize that fraction and do all the steps, and you can do the calculator way, plugging it all in, and lo and behold, you get the same answer. So if you have a major that you are well aware of does not need all these little details for the OCD math way, do the calculator way. You'll be fine. Let's see, 14. I do want to bring up one more thing real quick in case you guys go into calculus. There are really 2 methods for solving equations. If you have one variable, just a single variable, and it's the same degree, it's either x squared or it's y to the 4th or whatever, but it's one variable with a 1 degree, then you can get all that stuff, the variable and everything on one side and all the numbers on the other side, and solve it. If you can't do that, if you can't get all that variable into one little term on one side and all the regular numbers on the other side, then you are reduced to getting everything on one side and 0 on the other. Those are your only 2 choices. It's either variable, number, not variables, variable, single, and numbers, or it is everything and 0. 2 choices. So on 14, I have cosine squared x. That is a single variable for what I'm talking about. It's squared, but I only have one cosine x. The other thing's a 4. That's fine. So I get cosine squared x on one side. I get 4 on the other side, and I go to work on it with all the stuff I already know. Take the square root of both sides. I maintain my balance. I treat everybody fairly. I turn my cosecant upside down. I've treated everybody fairly by turning my 2 upside down. See what I mean by those 3 things? And then I worked it out. 15, I have a sine squared x and a regular old sine x. Those are not one variable. It's 2 separate things. And they've got a plus sign between them, so I can't put them together. They don't match. They're not like terms. So my only solution is to get everything on one side and 0 on the other. And that gives you many times multiple answers. Real quick hint, sine squared should have 2 answers. If I had sine cubed, should have 3 answers, but some of them are duplicates. If I had sine to the 21st, I should have 21 answers. So I did the rest of them. Let's see. Got a lot of multiple answers. And I didn't load the stuff from last time, so this will set a notes. It's no big deal. I think that'll do it for 7. I'll get them loaded, and you guys will have it all. Thanks.